So let's print some stuff, or at very least figure out how we're going to do that. So in order to print in any of ours and most 3D printers, there are some that can hook directly in. And in fact, Fusion 360 can function directly as a slicer to go into, actually, I think it does work for Prusa as well as, I think, several others. Either way, but I'm going to show you how to use a dedicated slicer software. So how this works, if you're unfamiliar with, basically your CAD software makes the thing. You make whatever, let's say convenient cube. However, you got to get it to translate to making being made with a 3D printer. And you take a 3D printer, it's essentially a two-dimensional printer that prints a bunch of layers. So the programs are called a slicer. It's not just a clever name. It literally takes your object and slices it into layer by layer increments depending on the thickness that it's preset to. What that means is depending on the thickness, that is the how fine the print is. So each layer, it's called layer height, pretty straightforward. If you set it to ultra fine, which it could be like 0.1 millimeter or 0.2, or usually rough is 0.3. So in terms of like printing a paper, think of it in terms of if you want to print an image or something, you have the full color setting or you have draft setting. Full color, it's going to use a hell of a lot more ink or whatever the material is. It's going to go a lot slower, but you're going to get a way higher quality image. Draft really goes much faster, uses less ink, image is less detailed or less rich, but you get it a lot faster. Kind of sort of the same deal with the slicer. You make if it goes thinner, you're going to have a lot. Now let's use finer lines. You're going to have a lot more layers, and it's going to take longer. But if you print it on draft setting, whoops, I forgot how to draw a square for a second. Thicker layers, less time. Yay, I made two different cakes. That's essentially how this works. So you take whatever image, whatever object, slices it into two layers. Now, these are all based on horizontal layers. So it stacks vertically, your z-axis. FDM printers, filament printers, start from the bottom and build upwards, whereas many resin printers, your object is actually hanging upside down, and the platform dips into a liquid reservoir tank and lifts upward. So it actually suspends your objects upside down. That's just a reference for how to orient objects and such. Now, for the first project, things are going to lay flat, no problem. The reason I note this as well is some new printers, they're designing ones that are actually either printing at an angle and printing on a moving conveyor belt, or some that are actually built around 5-axis printing to where instead of it just being straight, flat, up and down, the print heads can actually move and create much more organic slicing. We ain't got that, so we're going to ignore that. So how do you work this? Well, first you need a slicer program. Now, the two main ones are called Cura, and the one we'll be using is the Prusa Slicer because we have Prusa printers. So how that works, well, you download it. So where did my Cura go? There we are. The Cura interface is pretty much the same as the other. I just wanted to show you this real quick. You set your printer type, which means from a drop down, you can either add a printer or so. Then you select your material. If you have a whole bunch of options, because you do need to go through, unfortunately, exactly the maker, or just go to generic. Honestly, I've not had any issues using the generic settings for regular printing. If you're using a specialty type of filament, yeah, you need to go to the actual ones. And then you have your selections for how fine the layers and such. Now, this one, fine, is 0.15 millimeter. Takes a while. Coarse, draft, 3.3, coarse, 0.4, extra coarse, 0.6. So you can have some big chunks coming out of there. That's not really an issue if things are square and flat, but as we get into rounded objects, that becomes more of an issue. We'll discuss infill and such like that in a few. Don't worry about it. Now, this you go to Cura, download the software, you're all set. I prefer using, because we're using Prusa printers. You can, of course, print with Prusa. Bit of a tongue tie. I'm going to be using the actual Prusa printer slicer. So to get that, go to. Oh, sorry, one moment. Thought I had that dialed up. Where's my screen sharing? There we are. Sorry, bouncing between things. So you can just look up Prusa Slicers or Prusa3D.com and go to software, and it will bring up the slicer. Now, current one is 2.7.1. I am using an outdated one at the moment simply because it needs to be updated on this computer. So always use the most updated version, just because why not? So download that for Windows, or if you are on Mac, get the appropriate one. Same if you're on Linux, whatever. You can download the settings, you're all set. What that brings you to is the slicer. So it brings up a virtual environment of the correct size once you set this up. So you will need to go through the configuration. So when you first install it, what will come up is the configuration wizard. And I just want to show you this real quick. There's a couple of things you need to make sure of to get right. So you'll have your you'll have your welcome screen, and make sure you're hitting next for each one. Don't hit finish. Make sure you hit next. So it's going to first ask you which type of printer you have. We are using the Mark 3S models. So scroll down past the 4, the 3.9, the minis, Mark 3, and we are using a 0.4 millimeter nozzle. Make sure you select that. You can select other ones, but that's the only ones we have on there, so there's no reason to add that. So just hit finish from there. We don't have the resin one, the Prusa resin ones. Vendors you can ignore for now, but if you plan to use this for other printers, you absolutely can. This works back and forth the same as Cura can work for Prusa. Prusa can work for many other types, but we're just using it for Prusa for now. There we go. So again, next, if you want to make it all custom, more power to you. Now, the next thing is you need to make sure you're selecting what kind of filaments you can use. You can always come back to this, but the standards are going to be, it's going to bring up, of course, the Prusa line, because that's the ones that are being sold by them. But you can, of course, just go to generics and all that such. Main things we're using are PLA and PETG. We're going to explain what those are all later. But if you look on the second column, type, you have PLA, Prusa, sure, fine, whatever, but just generic is perfectly fine. So just scrolling down, just selecting generic, that's perfectly fine. It doesn't have to be the official one, because we're not using specifically ones. The one we're using are matter hackers, if you want to be specific. There you go. Same thing with PETG. I have a few extra ones selected because we do have a few other ones available. We'll go over that stuff later. But that's just the initial setup. You can select ABS. We do have ABS, but I don't recommend using that in here just because it doesn't print well and there's other issues. So ignore ABS entirely. Your own settings, check for updates, sure, fine, whatever. And then wherever you're going to have them stuff download, super duper. Again, more kinds of stuff. Yes, next. Now, these two file associations, these are just file types that will, so if you that'll be associated with opening through Slicer. So your standard ones are STL files, and we're going to discuss the newer format 3MF files later. But for now, that's the ones to check. That'll be the default settings anyway, so you're good. Yes. Leave it in default, advanced mode if you like. That's fine. Finish. Hooray! Okay. So that's just the initial setup wizard, all that kind of stuff. Anyway, you're back to, oh yeah, I got to change screens. Yep, still on Prusa. Okay, so that's your virtual environment. Now, the good thing is this is a one-to-one of the bed. So if you when you import your model, you can immediately get a scale size idea on this. So if you're kind of off on like, okay, I've made this all metric, I don't really know what 80 millimeters looks like, you can bring it in here and you can go look at the printers and see exactly how big it's going to be. or you could just know that it's that many, and you go get a ruler and go from there. So there you go. So just the same as it was with Cura, you have your print settings. You have 0.3 millimeter as draft. I usually keep with something like this, 0.2 millimeter for mid-range. You don't need to go with high detail. None of these are going to be high detail. It's a more of a diminishing return with those. I would keep it at one of the two. Quality, for these, again, speed. Speed is perfectly fine. I would keep with the 0.2 speed or 0.3 draft. It's up to you. You select your material. Again, I have multiple options here just because I've added a few more, but your generic PETG and your generic PLA. Right now, we will discuss those later, but for right now, the main things you need to know for us, PLA prints at a slightly lower temperature, and we have more color selection. PETG, slightly stronger, prints at a slightly higher temperature, and we have less color selection. That's pretty much the rundown right now. We're going to discuss what those all actually are right now later. The reason you're pre-selecting these is because they print at different temperatures. It automatically programs in the temperatures that it needs to use per the filament, which also means that when we get the printer itself set up, you need to make sure you have the correct type of filament. The color is irrelevant, but the type of filament is extremely important. And then obviously make sure you have the right printer set. We only put in one, so you're only going to have the one. We will discuss supports and infill in a moment. But basically, that's your slicer setup. So super duper, how do I get the thingy I made into this? All right, so let's pop back over to Fusion. All right. So I'll open up one of my examples. We'll go with, sure, why not the old Super Jedi, because we got all kinds of detail in there. Great. You got the old Rebel Scum. Couple of things. Make sure it's all one single body. If you have multiple bodies, go to Combine and select and hit OK, making sure to Operation Join. You need everything to be one single body. Also, you need to make sure that you don't have any floating random objects that are not connected physically. If you have something that's double-sided, that's perfectly fine. That's what we're going to go over with supports and such. But if it's flat, you're good. How to get this out of here? Go to File, 3D Print. Makes sense. So you can actually directly take this to a slicer built into Fusion. But in case you don't need to do that, and I'm going to show you how not to do that, because that's not what we're going to do right now, just uncheck the box that says Send to 3D Printer Utility. There you go. Obviously, you need to select the object. If you're having trouble selecting a single object, if you have a complex shape or you have multiple objects within here, meaning if you had a more complex project, you can just go to the drop-down tree, your project tree, and just select the actual body. You're all set. Right now, we're just going to leave it in the standard settings. Format, an STL file, stereolithogram file. Just leave it as such. That's fine. Unit type, they are in millimeters. Don't need to have a preview mesh. That just adds stuff to it. Refinement, these aren't overly complex shapes because they're not rounded, things like that. So right now, you could leave refinement to medium, or if it's default high, then just leave it at the default. That's perfectly fine. Don't even need to bother with the other ones at the moment. And then hit OK. Obviously, you need to say where it's going to go. This is going to your computer. Save to computer. There you go. All right. So that's saved. Fusion keeps hopping over to a different screen for some reason. If your computer does that when you finish a command or something and Fusion hops out, I don't know why it's doing that. It keeps doing it to me too. So let me swap over to the slicer. There we go. So you can either open a file, import an STL, or you can open up a new window, find your project, and drag and drop it onto the program. And there you go. Shows up, automatically plops it down. If you accidentally made this on a different axis, so maybe you accidentally built this on like the XZ axis, and it is, I'll just rotate this so you can see. If it's accidentally sitting upright or something like that, no problem. Don't worry about trying to get that to set down on the platform by hand. Select the object, and you have a variety of tools here. You can obviously move it around, selecting there, and just like in Fusion, you have your orthogonal drag, so you can only move it in one axis at a time. You have your scale option. You can scale uniformly and all that such. So if you accidentally made it too small or too big, you can always move it around here. You do have rotate manually, but the other option is called place on face. You select that, and you see how my object now has these kind of highlighted white areas. That is so it will no sorry. It will automatically detect the largest dominant flat planes. So a largely flat object, great. I just select the side, blam. It slaps it straight flat down on there. So main thing is if you're doing it by hand, it might accidentally have the whole thing ever so slightly turned, and then you're going to have to end up printing. It's going to generate a whole pile of supports that you don't need to have. So it's a really convenient feature. You can actually cut this up and do like color changes and such. We're going to talk about that in a bit. We'll talk about the rest of this stuff also later as far as painting supports and things like that. But so right now, those are the main ones. So there you go. You've got that selected. You've got your object in there. Now I need to figure out what to do with this. The one last thing in here is, while this object itself doesn't need supports, I'll show you how to do that, is infill. Essentially, what these types of 3D printers do, the filament extruder FDM types do, is it's printing the shell and then filling the internal space with some sort of pattern that just, some sort of webbing that just supports that outer shell, basically. Think of it if you've ever seen pictures of like a bird bone or something in half. It's that outer shell and then it has all that webbing and such inside. That's what this is. I guess I could have just picked like something like a wafer cookie or yeah, something not like bones, but whatever. You get the idea. If you need to change this, the percentage, 0% is it's completely hollow. That will not work for this because it's then trying to print on the base, fine, but then at the upper layer, there's nothing to support that. You have to have something. So something like this, I'd say like 10 or 15%, that's fine. Now, the default is it's going to print in a grid. Let me show you what happens. Let's say we're all done here. I like the settings. You go to Slice Now, bottom here. It's going to change screens. Look at the bottom here, bottom left-hand corner. Your original object is the cube view. The sliced view, a preview, is the stack of layers. Now, what you're seeing, what kind of looks like a wildly low resolution image, is if you zoom in, what it's actually showing you are the lines that the printer will extrude as. So you're seeing the different types of lines, and you have a legend here. The perimeters are in yellow, meaning the outlines. External perimeters, orange, very much outlines, and then general fills and such like that in red and other colors. You get the idea. I'm not gonna talk about that. Purple is an underhang, but in this case, it's fine because that's laying flat on the table. You also have this slider here. This will allow you to see cross sections as you go down through the object. So as it cuts through, you can see the webbing gets exposed. So as I said, the internal infill is a grid. There's your grid. That's what it looks like. So it creates this span inside. Now you can alter these, one for just preferences. Sometimes things are stronger with other designs, or you can also speed it up because on the bottom right-hand corner here, before you get to export G-code, which is how it's exported, it gives you a rundown of the stats. So how much filament you're going to use? 33. I think that's. Oh, right. It's in grams because it's in weight. And then also in meters, 11.3. Seems like a lot. It's really not. Filament cost. Yeah, it's giving you yada, yada, yada. Main things you really need to worry about, time. That's going to take almost 2.5 hours. Seems like a lot. It's not really using that much material. It's just taking that long to get all those details in. So let's see what happens if I change the infill percentage. Let's go down to 5% and reslice. See how much wider the span is? All right, save 20 minutes. That's not really great. This one's a kind of a detailed design. Now, how to access getting the other types? you go to print settings. If it's not showing up for you, if you have your interface in simple, just make sure you switch to advanced. That's all. Go to print settings, and it's the second one down, infill. Don't worry, we're going to talk about all this kind of stuff later, but for now, let's just focus on what we got. And it's the fill pattern. You got lots of options. My preferred favorite is this gyroid. I forget how it's pronounced. It makes wavy patterns. You can also change the fill patterns of the top and bottom surface. This one, monotonic lines, it's just back and forth. There you go. But let's change the bottom one just so you see a difference. Concentric, that makes sense. All right, so go back to the plater, hit slice now. About the same time. All right, well, whatever. In this case, it didn't really save that much because there's a lot of detail and such. But you can see the change in the pattern. Instead of this grid, it's a wave pattern. Looks neat. The other thing that I changed is the fill pattern for the bottom. If I zoom in, you can just see whoa, wrong one. You can just see that instead of a back and forth line, it's concentric line. So play around with those. There's some really neat ones to play with. It can just add features to your print. But like I said, this one just has, because it has all the extra layers and such, it's just more place for it to start and stop. All right. Say I like where that's going. Cool. Last thing you do, you go to export G code. Now, G code is the language that most CAM machines run in. So computer aided machining, that is the same kind of stuff that would run like a CNC lathe or mill or something like that. But in this case, 3D printer. Just so you're aware, that's what that means. The other thing is, inside the actual title, you can of course change it as you like, but it has the layer height, the nozzle type, as well as what material it is, and the expected print time. This is so when you select the file on the printer, you know exactly what the settings you need to have it at. What I mean by that is, this is set for PLA. I currently have PET loaded in the printer, so I need to change it over to the right material. That's all. So hit save, go from there. All right, now this part I can't record because this is all outside, but we use something different on here. So I'm going to hit stop on here and we'll change this up later.